When dealing with problems with distance, rate, and time, it's important that you start by making yourself a table. There's always going to be two separate trips. In this case, it's the blue and it's the yellow car. But in another one, it might be one airplane and another airplane, or a train and another train. It might be the same car going to the mountains and then back from the mountains. It might be a boat going upriver and then downriver. But we're going to be comparing two different trips. Next, we want to fill in these boxes, and keep in mind anytime you are referring to something that you don't know, then you need to stop and label that a variable. I'm going to use D, R, and T. Okay, so here we go. We have two cars, they're 600 miles apart, so I'm going to label that. They're 600 miles apart. They're traveling towards each other. One car's rate is 10 kilometers per hour less than the other car. This is the instance where it's referring to the other car's rate and I don't know it. So I need to call one of the cars R. It doesn't matter if I call the blue car's rate R or the tan car's rate R. You just arbitrarily make a decision. I'm going to say I'm going to let the blue car's rate that we don't know be R. The other car is 10 kilometers per hour slower. So in other words, it will be R minus 10. If this car was going 50 miles an hour, this car is going 40 miles an hour. Okay, next piece of information is that they meet in 4 hours. So if I had a stopwatch and I said, okay, go, and the cars start driving towards one another. And then as soon as they meet, I hit stop. Even though one car might have traveled further, they both traveled for 4 hours. So the times in both of these boxes are going to be 4. I don't know how far one of these cars traveled. So again, I need to label that some variable. For no particular reason, I'm going to label the blue car's distance D. I could label the tan car's distance D instead. Now let's think about what the tan car's distance would be. Let's pretend that the blue car went 100 miles. If they met in the middle, then this one had to drive 500. If the blue car went 200 miles, then this one would have to be 400. So if you think about what we're doing to get the leftover distance, it's 600 minus the distance the blue car travels. So 600 minus D. Okay, one more time. If this one traveled 400 miles, 600 minus 400, this one went 200. Now that we have the chart filled out, which is the hardest part, our chart is going to reveal the two equations. Rate times time equals distance. So this box times this box equals this box. And this box times this box equals this box. Okay, so carrying those over, 4 times R, these two boxes multiplied together equals this box, D. These two boxes multiplied together, 4 times R minus 10 equals this box, 600 minus D. I'm going to grab one of the equations. I'm just going to grab this bottom equation, put that up here, and you can't solve an equation unless it contains only one variable, either all R's or all D's. So I'm going to go with this other equation that I have here, 4R equals D, and I'm going to use that to replace this D with 4R. So substituting that in, then let's go ahead and finish solving. Let's distribute the 4 through. 4 times R is 4R, 4 times negative 10 is negative 40, and I have 600 minus 4R. Letters on one side, numbers on the other. So let's add 4R to this side, giving us 8R. Add 40 to this side, giving us 640. Lastly there, divide both sides by 8. And when I divide by 8, I end up with a rate of 80. In a story problem, we always want to go back and reread the question because we've done a lot of work and maybe lost track of what we're actually trying to find. And it says, what is the rate of the slower car? So if you take this R and you put this back into my table, you'll notice that the 80 kilometers per hour is going here. Well, how fast the other car is going to be this R, but minus 10. So 80 minus 10 is 70. So the slower car is going 70 kilometers per hour. If they ask you what distance did one of the cars travel, then you could take the 80 that we found here and substitute it into this equation, and we could find what the distance the blue car traveled, or I could take the 80 and substitute that in here to find the distance the tan car traveled. Okay, so let's do one more example here. This time we have Logan is driving to the mountains and then driving from the mountains back home. So my two different situations here, my two different trips to the mountains and going home. There was heavy traffic on the way there and the trip took 8 hours. So this time very quickly, it gives me 8 for going to the mountains is my time. So I'm gonna put 8 in that box. Okay, then it says Logan drove home, there was no traffic, and the trip only took 5 hours. So on the way home, I can put that the time is 5 hours. The average rate was 21 miles per hour faster on the trip home. So it's referring to the trip to the mountains. So I need to to go home. Oh no, that's right, sorry, blah, 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 my bad. So which one is gonna be R? So it's referring to the average rate is 21 miles per hour faster on the trip home. So whatever the speed was to the mountains, going home was faster, so I'm adding 21. All right, now for the distance, I don't know the distance from home to the mountains, but whatever that distance is, when I go from the mountains back to home, it's gonna be the same. Since I don't know it, I'm gonna call that a D. Okay, so here we have D, and going home is also D. Filling out these boxes, again, is the most challenging part, but now we can create our equations because rate times time equals distance. This box times this box equals this box. So I'm going to have 8 times R is equal to D, and then this box times this box equals this box. So if I'm multiplying these two boxes together, I'm gonna say 5 times R plus 21, and then equals D. You're gonna grab one of those equations. So I'm gonna grab this equation here. I want in the equation for there to be only R's or only D's. So looking around here, I see that I have this 8R plus D, so I can replace the D with 8R. We're ready to solve this equation, so let's distribute the 5. 5 multiplied by R is 5R. 5 multiplied by 21 is 105 equals 8R. Let's subtract 5R to get the R's on the same side. So we have 105 equals 3R. Divide both sides by 3 and I get 35. Once again, any kind of story problem, you want to make sure you reread the question, and we want to know how far does Logan live from the mountains. In this case, it's not going to matter if you put the 35 into this equation to find the distance to the mountains, or you put the 35 into this equation to find the distance going home, because both of those distances are the same. So putting the 35 in here, I'd have 8 times 35, or if I put the 35 here, 35 plus 21 multiplied by 5, and both of those end up being 280 miles.